We want to look at geometric progression. Geometric progression, GP or exponential sequence. So if it is called geometric progression, GP, or you call it exponential sequence. Given any sequence of terms T1, T2, first time, second time, third time, fourth time, up to the nth time, if the ratio between any time and the one preceding it is constant, then the sequence is said to be in GP. The ratio is called the common ratio, denoted by R. That is why you see that R here is equal to the last term divided by the preceding term. Meaning that even your R, you have your R can be the second term divided by the first term. It can also be the third term divided by the second term, and so on and so forth. That is how to get your common ratio. Now, when n is equal to 1, 2, 3, 4, and so on. Now, let us look at this question, example 1. Find out which of the sequence is a GP. Now, the first one here, if you want to find out any of the sequence is a GP, we'll say that the first one is the first term, which is T1. The second one is second term, which is T2. The third one is third term, which is T3. Now, the only way you can find out if this one is a GP or not is to be able to determine their common ratio. And your common ratio, which is R now, is equals to the second term here, which is 2, divided by the first term here. So the answer is 2. So this is your common ratio. Now let us also try the second one. Our common ratio is also the third term here, which is 4, divided by the second term, which is 2. 4 divided by 2 is 2. We can also check the fourth term, which is 8 now, divided by the third term, which is 4. So the answer is 2. 2, 2, 2, they are all equal. Then we say that this sequence, it is what? It is a GP, geometric progression. You have the GPR, you have AR, you have AR raised to power 2, you have AR raised to power 3, up to you have AR raised to power n minus 1. First term here, this is first term, and now it's like this. The second term AR is the second term, which is equals to this. The third term AR square, which is equals to this. And you have the nth term, which is AR raised to power n minus 1. We call this one nth term, which is equals to this. Now, you realize something in this, all what we have said so far. Realize something there, that whenever you are given, if you are to do 28th term, the 28th term is equals to AR raised to power 19. You will just remove 1 from your 20, give you this. Look at our nth term now. So meaning that the 28th term is just to say that put n equals to 20 in this one. You have AR raised to power 20 minus 1. You have AR raised to power 19. This is your 28th term. Now, let us move further and look at this example. If you look at this example 1 here, given that the GP 3, 6, 12, 24, find the 8th term and the nth term. Okay, now let us look at the first term here is A is equals to 3. And our common ratio is equals to second term divided by the first term, which is equals to 2. Or you can say that the third term divided by the second term, and so on and so forth. Now, you now have your nth term. Since it is 8th term, our n is equals to 8. So, if you are very smart, you can just say the 8th term is equals to AR raised to power 7. or which we got from the nth term equals to AR raised to power n minus 1. Put n is equals to 8 here. You have the 8th term equals to AR raised to power 8 minus 1. You have 7. So this is our 8th term now. So we continue. We put all our values there. Our A is equals to 3 times our R is equals to 2. 3 times 2 raised to power of 7. So what you have here, so answer is equals to 384. Now we want to get the nth term. The nth term is equals to AR raised to power n minus 1. But in this case, we have our A. The A is equals to 3 times our R, 2 raised to power n minus 1. So our final answer here is 3 times 2 raised to power n divided by 2 raised to power 1. Now, according to your indices, if you have 2 raised to power n minus 1, it's equals to 2 raised to power n minus 2 raised to power, divided by 2 raised to power 1. Because you pick one there and you subtract the power. That's what I did here. 2 raised to power n divided by 2 raised to power 1 is same thing as 2 raised to power n minus 1. So we can have our answer to be 3 over 2 times 2 raised to power n. This one will be our nth term. Let us look at the other example. The other example is that we should find the first 4 terms of the sequence whose nth term is equal to 5 into bracket 2 raised to power n minus 1. Okay, now if we want to do this, the first term is n is equals to 1. So, and our nth term we have been given here to be 5 into bracket 2 raised to power n minus 1. So, to get the first term now, where n is equals to 1, we'll say first term, anywhere we see n, we put 1 there, 5 into bracket 2, 1 minus 1, n become 1 here. So we have 5 raised to power 2 raised to power 0. So you have 5 times 1, and you have your 5, because anything raised to power 0 here is 1. So 2 raised to power 0 is 1. So you have this. You also have n is equals to 2. You have n is equals to 2. You have the second term is equals to 5 into bracket 2. You have 2 minus 1. You have 5 into bracket 2 raised to power 1. You now have 5 times 2. You have 10. When n is equals to 3, because they said first 4 terms, you have n is equals to 3. You have the third term equals to 5 into bracket 2 into bracket 3 minus 1. You have 5 into bracket 2 raised to power 2. You have 5 times 4. Because 2 raised to power 2 is 2 times 2, which is equals to 4. So you have 20. 5 times 4 to be 20. So we also need to get n is equals to 4. That's the fourth term. You have fourth term to be equals to, anywhere we see n, we are putting 4 there. 4 minus 1. You have 5 into bracket 2 raised to power 3. You have 5 times 2. You have 5 times 2 raised to power 3 means 2 times 2 times 2 give you 8. So 5 times 8, you have 40. So in this case now, the GPO is giving us 5, 10, 20, 40. So you have this as your GP.